Hey everyone, and welcome back to a long-awaited and highly requested demonstration. In this video I will show you how I built a custom 190-gallon plywood reptile cage completely from scratch. However, saying that it's just a reptile cage is a bit of an understatement. This tank was designed with versatility and efficiency in mind. That said, this exact design could be used for an array of different environments, including a desert setup, a tropical setup, a semi-aquatic setup, or anything in between. With minor modifications, it can also be altered to fit your specific vision or intended purpose. When designing this enclosure, I considered various elements from similar types of enclosures, both in the realm of manufactured and DIY projects. I determined what I like, what I don't like, and what can be improved. With that in mind, I tried to keep this enclosure as functional and aesthetically pleasing as possible. Being a DIY project, it was also very important to build this as cheaply as possible. As you can imagine, a manufactured 190-gallon setup bought at the store isn't cheap. So let's take matters into our own hands and make something that's arguably better than what you could buy at the store. The last thing I will say is that this is not a beginner build. It requires a decent amount of advanced techniques, and specific tools are also required. Regardless, if you are patient and crafty, you could easily create what you are about to see. So without any further delay, let's begin. I started out by cutting a few pieces of 3/8 inch thick plywood to various sizes with my table saw. I went with this plywood because it was pretty cheap, running at about $16 per 8x8 foot sheet. I should also mention that cutting this plywood would have been much easier with a circular saw, but I didn't have one at the time. Depending on the size of enclosure you wish to make, you could choose a thinner or thicker plywood accordingly. However, this design uses a lot of techniques to strengthen the overall build, so in most cases, you shouldn't have to go any thicker than what I've used. Here are all of the pieces that I just cut out, which will be used to make the shell of the enclosure. These two will become the sides, this one the back, this one will create a substrate tray, and this is one, along with a few other boards which will create a light compartment. Each individual section will be explained in greater detail as we go through this build. With these pieces cut, let's put them together. In true DIY fashion, I'm doing this entire build myself. That said, I propped up the two side panels using some 5-gallon buckets full of rocks. I also have these boards elevated on some 2x4s, so that I can easily attach clamps in just a moment. With these panels in a manageable position, I grabbed the board that will create the substrate tray. After applying some wood glue, I temporarily clamped this board in place on either side using a bar clamp. Rather than clamping the boards down until the glue dried, I attached the boards together using some 1-inch construction screws. Before doing so, I made a few lines to indicate the thickness of the side boards. Then I marked a few dots to indicate where the screws will go in, and I pre-drilled the holes. Pre-drilling is extremely important so that the screws don't split the plywood. Next, I inserted all of the screws into the holes. Once the screws compressed the boards together, I removed the clamps and excess wood glue with a wet cloth. I proceeded to add another screw to each side for additional strength. Next, let's attach one of the top pieces, which is for the light compartment. We'll use the same exact procedure as the bottom piece to do so. We'll put down a line of wood glue, place the board down and clamp it, mark for the screws, pre-drill the holes, insert the screws, remove the clamps, wipe away any excess wood glue with a cloth, and then add an additional screw to each side. After all three of these boards were attached, I carefully flipped the entire structure onto the opposite side. At this point, with one wrong move, the structure could have easily been broken. Next, I carefully set the back panel on top of the side panels. With the back panel in place, I added a clamp to one side of the structure. Then a bead of wood glue was applied to the opposite side. Now both corners of the back panel were clamped in place. Like before, the thickness of the board underneath was marked to drill for some screws. The holes were then pre-drilled and the screws inserted. You don't need a ridiculous amount of screws here, just enough to add a little strength and pressure while the glue dries. If you have more clamps and more time, you could easily do this without screws. However, using screws is less time consuming and easier. With this side done, the clamps could be removed and the same process could be repeated on the other side. Now, with all four of these pieces attached together, we'll tip the structure so that the bottom is facing upward. It's not as fragile as before, but care should still be taken at this point. Let's go back to the saw and cut several strips of plywood that will be used during the remainder of this build. These can be any width, but I cut mine to 1 inch wide. Several different lengths will be required and shown as we move forward. The first place that we put these 1 inch strips is along the inside perimeter of the bottom. Like the other boards, they were attached using wood glue and clamps. The purpose of these boards is to support the bottom panel and add additional strength to the overall structure. Next, I grabbed a few more of those 1 inch strips and cut divots into various sections. The purpose of these divots is to create an interlocking grid of sorts. The purpose of this grid is to create a strong interlocking system that will prevent the bottom from bowing downward. This could be done without making a grid, but I chose to do it this way to make the most of the plywood. With the grid attached, I could cut another board to size, which will act as the bottom panel. Then the main structure was flipped right side up and the bottom panel was put in place. It was a snug fit, so I lightly hit the edges with the hammer. Then I got some more of those 1 inch screws and drilled them along the edges of the bottom panel. Keep in mind that these screws are going through the first set of 1 inch strips that we just placed. Screws were then inserted from the outside of the structure into the side of the bottom panel. Even though these boards were cut precisely, there were a few gaps in between the bottom and side panel boards. To avoid complications with the sealant later on, I filled in these cracks with a bit of wood filler. Next, I measured 8 inches down from the top of the structure and marked a few lines. If you remember, I said that this area will create a light compartment. So depending on what type of lights you intend to use, make your measurements accordingly. I made mine large enough to accommodate various styles of light fixture. Using these lines as a guide, more of those 1-inch strips from earlier could be put in place. They were attached using a combination of wood glue and 1/2-inch screws. An important thing to mention is that the strips on the side panels are slightly shorter than the width of the panels themselves. This was done so that a strip of plywood could be added to the front of the enclosure using wood glue and clamps. Next, I cut a piece of plywood to the interior dimensions of the substrate tray and glued it into place. Like many of the other boards, this one will add more stability to the overall structure. Then I cut more strips of plywood, only this time around they were cut to 1 3/8 inches wide to accommodate for the thickness of the side panels. That said, these boards are for the front of the sides of the enclosure, one of which was attached using wood glue and clamps. Then a 1-inch strip was attached to the front of the strip that creates the light compartment. Once both of these boards were in place, the other 1 3/8 inch strip was attached to the left side. Next, I got another one of those 1-inch wide strips and attached it to the inside of the front of the enclosure. As stated earlier, the length of these boards is dependent on where they are being placed. Then I attached the same type of boards to the top of the main structure using wood glue and clamps. However, I left a 3/8 inch gap on the top of the light compartment to allow room for the top panel later on. I proceeded to add more 1-inch strips to various sections of the light compartment as seen here. Then I glued 2 square pieces of plywood to the center of the light compartment. I did this so that I could easily add 2 doors later on and make the compartment stronger overall. After getting all of the base strips in place, I doubled the thickness by adding another set of strips along the top. After these boards dried in place, I then attached another set of 1-inch strips to the bottom of the light compartment. I did this to match the thickness elsewhere and create a larger lip. Then I attached more of those 1-inch strips to the inside of the bottom portion of the light compartment using wood glue and screws. Next, I cut a few strips of thin pine board for the inside of the main front opening. I did this so that the separation between the pieces of plywood was easily concealed and to create a more finished look. Then I cut several strips of plywood to 1/2 inch wide. These boards were glued together to create several boards that were 3/4 of an inch thick, in other words, the thickness of 2 pieces of plywood. After drying, the new boards were cut to the proper length and attached to the inside of the bottom of the light compartment using wood glue and screws. The main purpose of these boards was to create a lip to attach a screen later on. Next, I flipped the structure upside down to reveal the grid once more. I drilled several holes at key points in the grid right through the bottom panel and then flipped the structure back over. Screws were then inserted into the newly created holes. This wasn't totally necessary, but I did it to create additional strength. Later I concealed these screws using some wood filler. Then I got some 3-inch wide pine boards and cut them at a 45-degree angle. These boards will hide the screws in the plywood and will create more structural integrity. After cutting them to the proper 45-degree angles and lengths, they were then attached to the bottom of the outside of the tank using wood glue and clamps. Then from the inside, I drilled screws into the newly attached pine boards. Initially, I only attached these boards to the front and sides of the main plywood structure. Then I cut 1.5-inch wide pine boards the same way and attached them to the top of the main plywood structure. These boards will perform the same function as the pine boards that were attached to the bottom of the structure. Again, they were attached using a combination of glue, clamps, and screws. Like the bottom, these boards were initially only attached to the front and sides. Next, I cut more 1.5-inch wide pine boards and attached them to the front and sides of the main structure. These boards will hide the unsightly corners of the plywood and add more strength to the overall structure, strength that will allow several plywood tanks to be stacked on top of each other. The pine boards were then added to the back of the structure accordingly. These boards were cut using a standard 90-degree cut instead of a 45-degree cut. I did this to make the build easier and because the back will never be seen. I also simply attached these boards with glue and screws from the outside since the back won't be visible. Remember those thin pine slabs from earlier? Like the main opening, I used these boards to line the light compartment openings. Again, I did this to hide the unsightly layers of plywood and to create a more finished look. Finally, I got some wood filler and smeared it all over the seams between the plywood strips. I did this to create a smoother surface for the epoxy that will be added in just a bit. Now we are in the home stretch. That completed all of the work necessary to create the main structure. At this point, it is extremely strong and ready to be sealed with epoxy or some other form of sealant that is safe for animals. Before doing so, I suggest taping off any areas where you don't want the sealant to be applied, in my case, epoxy. That said, I will be using Pawn Shield epoxy to seal the interior of this tank. I did extensive research on several different products, and this seemed like it would be the best and most cost-effective solution for my intended purpose. An added bonus is that it's pretty easy to work with. The way this stuff works is that it comes in two parts. Separately, these two parts don't do much of anything. However, once mixed together, they create a compound that cures into an animal-safe epoxy. It's commonly used to make plywood aquariums, seal concrete for ponds, and much more. Not only will this epoxy last indefinitely, but it will create a barrier that is suitable for various types of setups, as explained in the beginning of the video. Anyways, I measured out the parts accordingly, and added an additional part of denatured alcohol in order to thin out the epoxy mixture. This will make it easier to apply using a roller and paintbrushes. As you can see, this epoxy is white, but I actually ordered black. However, getting white epoxy was a happy accident because it will actually perform better for reptiles. This is due to the fact that black surfaces absorb light, while white surfaces reflect light. So whenever choosing a sealant, choose a color that works best for your purpose. Using a roller and some paintbrushes, I then applied a thin layer of epoxy to all of the surfaces I wanted to be protected from the elements. After allowing the first layer to cure for 24 hours, I cut out 1-inch strips of chipped fiberglass sheets. These sheets will reinforce the corners of the structure, making it truly waterproof. Alternatively, silicone can be used in the corners, but it won't last indefinitely. So let's do it right the first time and use some fiberglass. I applied all of these strips to the bottom section of the structure only. This is the only area that truly needs to be waterproof. After getting the fiberglass seams in place, I proceeded to add a second coat of epoxy. Next, I made some measurements on the back side of the light compartment. These measurements were used to drill 4 1¼ inch holes. These holes of course will be used to feed light cords through the back of the tank. I used a hole saw to create said holes. Then I added another coat of epoxy. After letting the third coat of epoxy dry, I added the fourth and final coat. You may be able to get away with only 2 or 3 coats of epoxy, but I made it very thin so that it was easier to apply. With the fourth layer now dry, I removed all of the masking tape from the front of the structure. Next, I got some standard metal window screen frames which are used to make normal household window screens. I measured and cut all of these pieces to the dimensions of the lip of the inside of the top structure. Then I did a dry fit to make sure that it would fit properly into the lip created by all of those layers of plywood. Afterward, I got some aluminum screen and attached it to the frame using a spline and a spline roller. Finally, I cut off all of the excess screen with an X-Acto knife and spray painted it white. The spray paint isn't necessary, but I wanted to protect the aluminum from corrosion long term. I would rather take measures to eliminate problems before they occur, rather than mend them later on. Then I measured the inside trim of the top of the structure. Using these dimensions, I cut a piece of plywood to size. This piece of plywood will be used as the top panel. Before this board could be used though, I had to apply some epoxy. I added 2 coats of epoxy to a single side of this board. It was much easier to apply epoxy to a single surface. That said, I was able to mix the epoxy a little thicker, and in effect pulled it off with only 2 coats. Next, I got some 100% silicone and ran a bead along the entire lip where the screen will go. With the silicone in place, I gently set the screen on top of the silicone. Afterward, I screwed the screen down using some zinc screws. Then I ran another bead of silicone along the top of the screen. The purpose of the silicone is to conceal any possible cracks where unwanted pests could possibly sneak in. So it's not really necessary, but as I stated earlier, I want to take all the precautions necessary to avoid any problems. Now I ran another bead of silicone along the top trim of the structure. Then I placed the top panel with the epoxy facing downward on top of this silicone. I used some weights and clamps to keep the board in place while I inserted screws along the edge of the board. The silicone of course will seal any gaps, and the screws will hold the board in place. With the board screwed in place, I applied another bead of silicone, but this time to the inside seam of the board. Much like the other beads of silicone, this one was not at all necessary, but I figured I would do it just for the heck of it. Next, I put a generous amount of wood glue on the top board and placed another piece of plywood on top of it. Then I set several weights on top to apply pressure while the glue dried. This board will prevent the top from bowing if things are placed on top of it. Then I cut 6 strips of plywood and attached them to the top using wood glue and screws. The placement of these boards is specific to what I want to stack on top of the tank, so I won't explain much about them just yet. I finalized this section by adding some wood filler to conceal the screws and any gaps. With the main structure complete, it's time to create the doors to the enclosure. I began by setting up my table saw to make some dado cuts. A dado cut is essentially just a groove or slot cut into a piece of wood. They are very useful and can serve several functions. In this case, it will hold a pane of glass. So I ran several 1.5 inch wide pine boards through my table saw dado rig until I ended up with several boards that looked like this. Next, I set my table saw to a 45-degree angle and cut these boards to various lengths. Here is one board that will be cut in half to make 2 boards. As you can see, it doesn't fit in place. The reason that this board doesn't fit in place is because I accounted for the thickness of the blade, which is 1/8 inch thick. Essentially, this board will be used to create 2 doors. If you've ever worked with doors or cabinets, then you know this board cannot simply be cut in half to create some doors. In other words, this would not be possible with a standard 90-degree cut. So instead of cutting at a 90-degree angle, the boards were cut right in half using a 45-degree angle. As explained earlier, alone this board was too long. After making the 45-degree cut, they could then fit properly. Simply put, the 45-degree cut allows the doors to close as tightly as possible without having a center brace. So after cutting these 2 boards right in half, we ended up with 4, which were then clamped in place. With these boards clamped in place, I then used them as a reference to cut 2 additional boards, which were used to create the sides of the doors. Now the doors could be put together. I started using some clamps and wood glue to hold all of the pieces firmly together. After the glue was dry, I clamped the doors onto a table. Then I drilled some 3/8 inch holes into the sides of the door. These holes were then filled with the 3/8 inch dowel rod, which were glued in place. This isn't necessary, but it will add additional strength to the door. Next, I drilled some 2.5 inch construction screws into the top and bottom of each door. Unlike the dowel rod, this screw is necessary because it will add a lot of strength. I then trimmed the dowel rod with a saw and used some wood filler to hide any imperfections. I should mention that there are more effective ways to make doors like this, but I tried to keep it as simple as possible. Also, we will add something later on that will make these doors even stronger. Next, we can make the second set of doors. These ones will be used for the light compartment. They're composed simply of a set of boards with dado cuts and a 1/8 inch piece of plywood inside of said dado cut. All of these boards were assembled simply using some wood glue and clamps. Now it was time to sand everything. I started out with 60 grit sandpaper and eventually worked my way up to some 220 grit sandpaper. In the end, creating a silky smooth surface. I then repeated the same process on both sets of doors. Next, I could finally stain the exterior of the tank. I always start out by wetting the entire surface with a damp towel. This helps remove any excess wood dust, and it opens the pores of the wood to better absorb the stain. After dampening the structure, I let it dry for about 5 minutes and then proceeded to add the stain. I don't like to use a brush to apply stain as I find that it makes a mess and doesn't work well. That said, I apply my stain using some old socks or other fabric that would otherwise go to waste. It goes without saying that if I would have painted this thing a single color of paint, it would have been much less work. But I really appreciate the finished look of stained wood. I mean, seriously, look at that grain. After letting the first coat of stain dry, I added a second. Then I got some Varathane triple thick polyurethane. I wanted to try this out because I really like a thick coat of poly on my builds, and I wanted to try a new product. Normally I have to apply about 6 layers of traditional poly to achieve the look I like. However, I was able to pull it off with only 2 coats of this stuff. Additionally, it dries extremely fast compared to traditional polyurethane and has no offensive odors. I highly recommend it. Next, I proceeded to stain the doors using 2 coats of stain just like before. After getting the doors stained, I felt that the easiest way to apply the polyurethane was to first attach the doors to the main structure. To do so, I began by clamping the doors in their final place. Then I got some standard 3-inch wide brass hinges and put them in their respective locations. With the door securely in place, I then applied 2 coats of polyurethane just like before. Then I flipped the enclosure on its side and put a coat of polyurethane on the bottom to better preserve the wood. As is, I'm not sure if the main doors would be strong enough to hold a pane of glass. That said, as long as the corners of the door are strong enough, this won't be an issue. So I simply attached a brass L brace to every corner on the doors. Initially I didn't want to do this, but I actually like the way the brass hardware looks against the stain. Next, I added a bread drawer clasp to each one of the doors on the light compartment. I really like to use these because they're easy to attach and work well. They will do an excellent job of keeping these doors closed unless opened. Then I added some brass slide bolts to the doors. There's a lot of hardware that could be used in place of these, and probably some better options, but I chose these because I felt that they would work well and look good in the process. With all of the necessary hardware attached to the doors, I could finally put the glass in place. I got 2 pieces of 1/8 inch glass cut at a local hardware store. However, before they could be used, I had to sand all of the edges using some sandpaper. I really only had to sand one of the edges, but I did all 4 just to be safe. Anyways, with the glass now prepared, I added a little silicone to the dado cuts on the doors. I'm using brown silicone 2 because it will blend nicely to the stain, and silicone 2 adheres better to surfaces like wood because of the way it cures. With a little bit of silicone in place, I simply slid the glass into the dado cuts. Then I closed the doors. Using a gripped glove, I fine-tuned the position of the glass so that the placement was optimal. To ensure that the glass stayed firmly in place, I put down 3 strips of Gorilla Tape. Afterward, I taped off all of the glass to create an even bead of silicone in just a moment. Next, I siliconed the left door, evened it with my finger, and repeated the same process on the right door. Finally, I removed the masking tape and let the silicone cure for 24 hours. Then I opened the doors and repeated the same process on the inside. The silicone will not only keep the glass in place and create a nice seal, but it will actually make the door stronger as well. At this point, the tank was finally ready to come inside. Then me and my brother carried this into the room and set it on top of a 2x4 stand that I built. I didn't show this process because it's not directly related to the build. I just simply didn't want the plywood tank sitting directly on the ground. Now for the finishing touch. I was concerned that my snake would be able to sneak out of the doors as is. He is named Whodini for a reason, and I wasn't going to take any chances. So, I attached some magnetic catches to keep the doors securely shut at all times. I really didn't want to add these because they're a bit of an eyesore, but they were the best solution I could come up with at the time. At least they're brown, so they blend in with the rest of the structure relatively well. And here is the final product. I'm truly pleased with how it turned out, and quite honestly, I think it functions just as well as it looks. Something that I think really sets this design apart are the doors. I really don't like the idea of having a center brace. Although they are quite functional, they really are an eyesore. The 45-degree angle on the doors is the feature that made it possible to omit the center brace, and even though this is such a simple feature, it took me a really long time to come up with it. Another feature to the doors that I really put thought into is the way that they close. The frame of the door is flush with the viewing panel rather than being a part of it. This allows for a better seal, which is really important when trying to retain heat or humidity within the enclosure. It also helps keep the animals in and pests out. I also think the light compartment is a very useful feature. I don't know about you, but I don't like the idea of having my light fixtures inside of the enclosure itself. By this, I mean that a lot of times it's necessary to put an ultraviolet light inside the tank itself. To avoid this, I simply made the light compartment. It will also hide those ugly light fixtures and provide some nice cord management. And the main compartment, of course, is coated in epoxy, so it will stand up to the elements and any abuse that your beloved animals will send its way. Since the whole structure is made out of wood, it could be easily modified to include overflows or other plumbing necessary for semi-aquatic animals. Anyways, I really put a lot of thought into this design to provide max aesthetic beauty while also keeping it very functional. This is not the last you'll see of this project, as I'll explain more in a later video. If this video is hard for you to follow, I will be releasing an abridged demonstration for other enclosures just like this. Anyways, I hope you enjoyed this build and learned something useful. As always, I thank you for watching, and I'll see you next time.